Yeah.
Okay, many thanks to everyone. Many thanks, Riccardo, for inviting us for this session. We are very happy to share what is our vision for the construction sector in 2040 and to share also what are our experiences in general, who we are, in which particular sector we work, and which technologies we develop. First of all, we gave the title to this presentation, The Journey to Construction Sector 2040, because 2040 may seem to be very far in the future, but actually many things have to happen every day in order to make the construction arriving to a different stage in 2040. So we develop a vision, and now we're trying to arrive there day by day. Ari, can you tell us a little bit more about Moog, who we are?
Yeah, I think the Moog is a 70 years old company, and our focus is around motion controls. And also we say that around the motion controls, when performance really matters, we like to do a challenging applications. I think if you look about, it's a reliability of the system when you go to the space. You only have one chance. It is also the safety when you are flying. The plane must stay in the air, and it should go where it goes. In the industrial, it's quite often the productivity. I think in a flight simulation, it's a fidelity of the training and how you feel about it. It needs to be very real. And also oil and gas, it's a lot of safety and reliability in these kind of areas. Our size is about 3 billion, about 13,000 people, probably 5,000 engineers. And the biggest business is aircraft. We are the industrial, about 900 million, that's where we are coming. So this is a very short snapshot of the Moog. So Francesco, why don't we introduce ourselves? Probably you would like to start.
Yeah, definitely. Francesco Mazza, Business Development Manager for the team Growth and Innovation here in Europe. I'm an engineer, mechanical engineer, even though I've spent all my career more in business development. In different sectors, I started with automotive and then I moved to energy, renewable resources, and now more in motion control. Been working in Europe in different countries. I'm Italian, but I live in the Netherlands. I had considerable long experience in abroad of Europe, also so in South Africa. If you see my career, I started more as a sales engineer, then I moved to position as a product manager, and then to business development manager. Ari, you want to tell me something more about you?
For sure, yeah. So my name is Ari Almqvist. I'm the Group Vice President, and I'm nowadays the Director of Growth and Innovation. I have been in Moog more than 30 years in different roles. In Finland, that's where I started working for Moog. I have been in Europe in different roles and in different locations, basically in Germany and the Netherlands. And last 7 years, I have been working in US. So that's a little bit of my background is automotive engineering. I have also some education in aircraft business and also have some business education addition to my engineering background. So Francesco, why don't we talk a bit more about what is the topic today?
Yes. We like to say that we are new in town, actually. Definitely, probably you don't know Ari, you don't know myself, but even the word Moog is not extremely easy to be connected to the construction sector by now. First in mind appear always the concept of Moog as a company working in an aircraft group in aircraft sector. So for us, actually being here, participating into this meeting is like being to a new town. Actually, we organized this team. So the team of the people coming from different town in our wandering years, actually. So this is a metaphor that is describing people that in Europe since Middle Age until now, when they finish their bachelor, before becoming a craftsman, have to move to a different country in order to develop different experiences and different capabilities developed in other countries. At the same way, we come now to the town construction, bringing the experiences and the technologies that we have matured in other sectors, like the aircraft and the medical devices sector. Ari, where this sector is going, in your opinion? What is our vision for this sector?
So I think, Francesco, thanks for asking that. I would probably tell a little bit about background first, that it's not completely, we are talking today a lot about new experiences on the different areas, but I also want to kind of to talk a little bit about that it's not completely new town. We have been and we are involved with the mobile equipment, mainly a bit more on the demanding machines. Here you see some of the examples. Some of these are automated, some of them are pretty futuristic, some are quite high productive machines here, some has been remote controlled. And as I said, if I even take my own working in Moog, when I started in Moog, I was in Finland, I probably spent 70% of my time in the mobile equipment. So that was the biggest market for myself in that stage. So it is not that we are completely new. I'm sure we are bringing some of the new experiences on for this market. So probably next time it's a little bit talking about our vision and the kind of the road to 2040. Until now, we said, we are talking today quite a lot about energy efficiency and electric systems. We probably have tens of thousands of these systems made until now, which we are showing some examples today. Why don't you, Francesco, talk a little bit about what is going on now today in automation and electrification, just that we are really working about the vision. It's not just we are sitting and dreaming, we are doing some real work.
We are really trying to make our feet in the ground. First of all, on the electrification side, we are working on making machine electric. Actually, for us, our goal, we even check the possibilities of full electric machines. So not only electric powertrains, but also electric actuation system, in order to improve the performance of the vehicle and decrease the energy consumed by the vehicles. We are already developing several prototypes and some pre-series of different models of vehicles in this year, 2019, 2020, we have already done. We have already checked also these vehicles with the end user to try to understand if they feel comfortable in driving and controlling a new machine, and we got quite a positive answer from the end users. And in the next couple of years, we are going to scaling up with the production of this vehicle, the area where we are particularly focused is the compact sector of the construction sector, the compact segment of the construction sector. In parallel, we are also working in trying to increase the automation of the vehicle. Actually, we have this challenge of 1,000-mile autonomy. We are experimenting different prototypes in different segments of the construction and of the agriculture. These autonomous vehicles are not completely autonomous, don't they, Ari?
Some of these things, I think, like this machine, what we had, this 1,000-mile autonomy, that was completely autonomous. Some of the equipment, what you see here, only some task is, example, the transferring the material is automated. So this depends, and I think that's how it's going to go. That you do the sum of the part of the things, and you still probably in the next few years use human beings in some part of the task, but there are a lot of like transporting materials which can be automated. already. And these are the things what we are working on, also some kind of optimization to work outside of the factory. So a little bit bringing also the lean outside of the factory. So and as I said, we're talking quite a bit of innovation and new things. I would call this like a practical innovation. We do real things with real customers and real end customers and doing real machines. And also we are showing on part of the today's presentation how we are able to move quite fast, because most of these technologies we already actually have in hand to start with. So why don't we talk a little bit about the vision of the construction 2040. So Francesco, would you share a little bit your thoughts? What's going to happen?
Can I start with 3 words? Electric, autonomous, and connected. So this is how we imagine the construction site, in this case, the outdoor. So what we envision at this stage is, and of course, things can also change, is that there will be much less people on the construction site comparing with now. A huge amount of data, flow of data going from humans to the machine and to the database where this data will be analyzed and will provide real-time information related to what is happening on site. A lot of drones or robot or even small robot that can provide a continuous check-in of what is happening on the site. And in terms of features, we are imagining fleet management and material movement being regulated by data. Ari, do you say in the same way also the outdoor and the indoors as well?
Yeah, I think we have also starting to look about a bit more about the indoor stuff, and I think it is probably the same topics as you mentioned. It's autonomy, electrification, connectivity. That is also happening inside. I think we can vision more on the robots coming, and probably some of these are walking, some of them with wheeled, and some of such specific tasks supporting people to do the work. That is going on. We are probably not that far as we are in electrification. We are kind of preparing technology to support that, but we see the role of the robots, probably even some type of inside drones to mapping what's going on and the progress, and also moving the material. So it's the moving material with more part the wheeled equipment. That is probably what is going to happen. It is still probably more vision here, but some of the areas we are working, and sometimes we are also working with some research institutes to kind of to painting the picture what the future is going to be look like. Is there anything what you would add here, Francesco, for this?
I think it's a pretty clear picture, actually, that you map now. The only thing that I would like to add is that we are really trying to play with the different actors of the ecosystem, and we really would like to understand what are the pains and the challenges of the end users. And so the construction companies and what are their challenges, and especially what we heard from these companies, that there's going to be quite a considerable lack of qualified labor for the construction in North America and in Europe, and this brings the need of a higher level of automation and a solution to support the humans on this side.
Right. So other thing here is that talking about these other towns and the learnings what you do somewhere else, I think some of the engineering topics we have also learned from the nature, watching how the birds are flying, and I think that was some of the ideas where people say, why don't we put the winglets to the airplane to make it much more efficient and reducing track to the lift ratio. And the other thing is some of the tools, learning also how the nature is. So we are applying a same principle a little bit here. If you look about some of the machines, what we have done in the past, like example here is the mobile material movement here. Even the equipment looks quite different. And I think that is also some of the advantages we have, that we can basically take some of these designs and using the similar kind of qualification, and actually we use even some of the technology more or less one-to-one inside and putting it to mobile equipment, which probably have a bit more different challenges on the cost point of view and some other stuff, but it's a lot of areas that what we can translate from the other learnings to this market, and I think that has give us agility and speed to doing this work with our customers when we are collaborating. Francesco, do you see it the same way, or is there something you would like to add here?
I think I see in the same way, and I think we want to tell more about these technologies. What are the technologies that we feel are relevant for the construction as well? So maybe, Ari, we can move to the next slide.
Yeah, I think here is some of the talking more about the energy efficiency and a lot of driven through the electrification and of course the kind of the power on demand. Plastic machinery, either injection molding or blow molding, a lot of things has gone electric, at least in a certain size of the machines, and it has a dramatic impact about the noise level and the energy consumption. Defense, there is some examples where you have really gone to the hydraulic actuation systems, to the electric systems, again, much more efficient systems, also very reliable, easy to storage and take in the use again. So that's one of the advantages. Aircraft also moving to the electric flight controls, slowly but surely. We know that the hydraulic has a pretty high reliability on. It needs to be through electric, and that's, yeah.
Go ahead. No, I've lost you for a second. Go ahead.
So that is also happening to kind of qualifying them, and again, same thing, more electric, more efficient, less maintenance, flight training, the using also electric motion bases. Actually, even these motion bases, sometimes the payload where it is moved, still probably around 1g acceleration, can be up to 25 tons. So it is amazing what power you can nowadays achieve. And if you look about this technology, it's typically digitally controlled. That's what it brings itself. It's pretty easy, typically put closed loop controls, very high efficiency through the permanent magnet motors. And we can also optimize the actuation devices for in different kind of the application. And if you think about what are the results, can you share a few things what we have been experienced so far, Francesco?
Increased performance. This is the most relevant one. So when you want to go with a higher performance, and this can bring the sector moves from hydraulic to electric in that moment, and this brings immediately a huge reduction of energy consumption. As we said, up to 80% of the energy consumption, and also reduction of leaks and maintenance cost. Definitely also moving from hydraulics to electric bring also us a step closer to the automation. That is probably another topic extremely relevant as well. In general, I guess the energy efficiency, as we can see also from the next slide, is an extremely key topic for the next trend, the trend of the zero emissions. So,
yeah, I think, Francesco, so I think you mentioned the zero emission. Probably you would talk a bit more further because the energy, amount of energy you have in your system is somewhat limited. So you need to work on to reduce the energy consumption, and it's much more critical than it has been the industrial combustion engines, because you have a diesel, have a lot of power source. So why don't you talk, Francesco, also a little bit about this, what we have seen so far?
Absolutely. Let me say, so going to electric with an electric batteries that is moving the construction machinery need a certain level of energy efficiency of the full machine architecture, because as we all know, the battery density of the energy density of a battery is much lower than the diesel, and consequently we have to create some form of efficiency. This is happening in different sectors, I would say. In the aircraft, there is this movement from to electric batteries as well. What is bringing, Gary, this to the sectors?
Yeah, I think it has a lot of advantages, because I think of course you can have a different use cases where the emissions are limiting the usage of the combustion engines. I think also you can reduce the noise, which is actually making the working environment much better. Also, the energy cost is going to be dramatically reduced, and also most cases we can provide a better performance. So even it's not actually what we are so excited just to put a battery and replace few motors. The nice thing what we really like is to making it better performing and actually make it automation ready. So it's pretty easy to, as you mentioned earlier, to add some automation capabilities. The technology is there. You also probably, when you design the machine, you can use this disruption as an opportunity to think about how you make the machine stiffness and some other stuff, that it is really also from the machine design point of view, structural point of view, ready for automation. Because as we also have seen, that when you try to automate more these machines, the machine structure needs to be also prepared for that. So why don't you talk a little bit about what we can do to help user and probably enabling some different use cases?
Yeah, what we are trying to do actually in this case related to remote control is putting at the center of our focus the safety of the operators and the productivity of the machines. We're trying to improve the safety of the operators, because as we know, sometimes some construction site can be particularly dangerous. And so how to do it? We would like to put the operator outside the cab of the machine, and from them being capable to control one vehicle, or eventually at a later stage, more vehicles at the same time. And this will also bring a higher level of productivity of this vehicle themselves. How do we do it? First of all, it's a road also in this case. It's a different level of automation that we're bringing on the vehicles. What are the first one, and what are the next step actually, Ari, that you see in this field?
So first of all, we can use the technology what we have to, like here to controlling the chassis automatically, which makes the difference that you can really take by myself, I'm not an expert on the excavator, and typically it has been taking months to get somebody to able to use this kind of complex machine. They need to operate 14 axes to be able to drive the machine. I can sit on the cabin, and in 2 minutes the guy telling me how to push the joystick, and I'm ready to drive. And actually, I'm actually driving better than the experienced driver manually can do it. So and it's safe because it's monitoring. So this is kind of the making it easy to use and faster to train, and focusing also the work thing, not about the stabilizing the machine, it's focusing on the work to be done, which is including the productivity. And of course, then the other thing is that this enables this machine to be used in a dangerous area. So if there's an explosion risk, as in some of these cases, or there's a landslide or whatever areas, the catastrophic areas, you can really put the machine to doing that, and in the worst case you lose the machine, but you don't lose any persons. So you can really start into recovery of these kind of things much faster. So this is one of the example of different use cases. Here we also use the some level of simulation, so the driver has a little bit motion feedback, what is happening in the machine, to get a better control, and of course the good visualization. So these are one of these technologies what we are working on, and also looking about what auto digging would mean and some other stuff. So this equipment is well enough equipped that it's ready for for the auto digging, and this is really what is the next thing what we are developing. And sometimes with some of these works also we work together with universities. So this leads actually to the autonomy, and probably that is something. Is that also again you want to talk a little bit about, Francesco? What is happening within Moog about the autonomy?
In Moog, we are doing several prototypes related to autonomy, several machines that are running in fields of the construction site and on agriculture site, in big orchard, huge orchard actually in North America, where we are experimenting complete autonomous vehicles that are capable to do geolocalization and navigation with several sensors in order to perceive what is the reality and perceive a change in the environment where they are playing. So these vehicles are capable to detect obstacle and also to react to the presence of obstacle and to react in order to achieve the goal and do the job that has been that has been asked to do. Big advantages of these machines. First of all, they will be capable to work 24 hours a day, 7 days a week. And actually, we are we are thinking how to bring this in extremely dirty and extremely difficult environments. Any example of this environment, Ari?
Yeah, I think it's. I would probably go before I go this environment is also that we have been working probably now 10 years also with the air equipment we call it optionally piloted helicopter, which you can have a pilot on, or you can run it without pilot remotely or totally automatically. Also same with the kind of the last mile delivery things. That's actually where we acquired a company with some of the capabilities. But it is interesting also to think about that when you have this level of sensors on the machines, we have also learned that sometimes the more value is the data what you capture than just the poor autonomy itself. And that's what you mentioned in agriculture, the data to manage in the growing season and to make a decision what to do and automate some of the actuation, like an apple orchard. We have actually increased the productivity quite dramatically to optimize in the growing. But you can use it in the different environments, like delivering solar panels, and as you said, it's also having less people on construction site. That's optimizing to reducing accidents. We can optimize also the movement of the machines, which is optimizing kind of the energy requirement. And of course, it's the same problem here. Some of these sites, it's difficult to get people to work on them. So more you can automate it, less people you need. And you can also have these work environments where people are not happy to work on to be done, because, as I said, there are many areas where there is a real shortage of the working, and especially very remote sites, somewhere in the middle of Arizona. Nobody wants to work there. So that there is a more and more pressure to create this automation autonomy going forward.
Thanks, Ari.
So I think I probably continue a little bit of the cybersecurity here. I think this is probably a critical topic, and we will also ask a little bit, say a few words about that. I'm not going to go too much on details here. If there's really a stronger interest, we are happy to create a separate presentation about with our experts who are working on. But I think it is like everything else. When you want to make something safe and working well, it needs to be well thought out. So it is starting about the design and the architecture. So what you do on the machine, how your edge thing on the machine is going to look like, who has the access, how you control the access, what is the access locally, what is the access through the air. All these things needs to be well thought. We have again a bit advantage here because we have done similar kind of stuff in industrial stuff too, where you control who has an access of what. The connectivity is the next stage, how you create the secure connectivity. That's also probably where you partly need to rely on your partners to helping that. We are not the connectivity or the mobile connection experts, but we can define what we need and what we want and how we create that safety that nobody can't disturb it. And if they can disturb it, they can't access of any of the equipment, either on the edge side or on the cloud side. The cloud tools, it is also important, and having a powerful tools and safe tools. The one thing is they need to be safe, but they need to be all accessible, because we have third parties and customers who want to access our systems. So you need to have a safe, easy to use interfaces on that. And of course, then the storage. That's probably where we also, as most of you probably are trusting on the existing major cloud service providers and using them, then their services. And of course, then we use some of the machine learning here. So this is kind of what is going on. It's going to be evolving. It's going to be a development, but I think we have a pretty well thought concept. And as I said, if there is a more interest to go deeper, we are more than happy to create an extra presentation with our experts about that area. So I think there's a lot of transformation happening here, and to enable this transformation, would you, Francesco, give some of your thoughts? What do you think is needed to make a transformation really happen?
3 pillars. The vision. The vision is extremely important. So we have to, first of all, imagine where we want to go and then take action to arrive there. But the vision itself is not enough. I think it's important to have relevant experience, have tested technologies and capabilities developed in place. And still there is a second big pillar that the vision is rely on, that is the collaboration. So our team collaboration, in our case, we're talking about, as you said, around 5,000 engineers that are working in different environments, in different sectors, but still trying to bring the best solution and learning from different fields and applying technologies from a field to another. But collaboration is also a bigger word. It's not enough one own company. If we are today here, it's also because we believe in the power of the ecosystem, in creating connections and bringing each other experience and building to each other actually capabilities. Do you see it in the same way, Ari? Do you see that these are the things that we are also bringing on the table?
Yes, I think it is true, and I think the one thing is, if you go the kind of the right hand picture, is to having a right teams. The experience is a lot of that is, of course, it's ahead of the people. Some tools helping it, but to have putting the right teams together, and I think that goes probably part of our culture. We are pretty collaborative inside the company too. And we are definitely collaborative with our customers. But we some of these topics what we have talked today, we work globally. Sometimes we have 5 different locations worldwide working together. And of course, this COVID has now even putting more pressure on to how to work also virtually effectively together. But we have been doing that even before. So that's why I think the COVID was even not such a big challenge, because we have had a global teams working for the last 20 years. So that is really critical to put the right team together, and also many cases having it reasonable near to the customers is always also helpful. So that's where our global footprint is also a good thing to have. So we can have a good way of collaborating. So I think I agree on you, and I think all this together, what we kind of have a little bit of our vision statement is making impossible possible. You can't probably change the physics of laws, but you can push the boundaries when you have right people, right technologies, right experiences. In many cases, we have made things which people didn't believe is possible. And as I say, this is where the collaboration is also important, and many cases we have done together with our customers, working together closely to putting the really good solutions together. So in Moog, we like challenges. It is when performance really matters. We want to make the better machines. That's our vision. So now it's probably time for the question and answers.
Yeah, we've been a little bit longer. If I look at the time, 56 minutes.
No, but that was, let me stop.
I think we have been a little bit long.